So welcome everyone to MRI Magic Tricks. So, where are we? My name's Charlie Somerville. On Twitter, I'm Charlie Sum. You can probably tell by my accent, but I'm from Australia, from the city of Melbourne in particular. It's a really nice place you should visit sometime. Anyway, yeah, I work at GitHub. I work on the systems team there, doing a lot of performance stuff, and I get to spend a lot of time digging into Ruby itself. And related, I do a lot of work on Ruby core, doing a lot of performance stuff and also a lot of bug fixes. And yeah, that's the sort of work that's let me sort of dig in and find the sort of bugs I'm going to be talking about today. So MRI Magic Tricks. What I'm going to be talking about is 3 different MRI bugs and how you can actually take advantage of these bugs to bend the language in crazy ways and to really push the limits of what you thought was possible in Ruby. And I just want to say that these bugs are specific to MRI. They don't affect other implementations, so JRuby, Rubinius, they're not affected. These are all bugs in the specific logic inside MRI. And I also want to give a bit of a disclaimer. This talk doesn't contain any useful information. Don't try this at home, and certainly don't try this in production. So with that out of the way, let's begin. So the first magic trick that I'm going to show off today is the frozen core. So in MRI, there's a handful of hidden secret methods that are called internally by the interpreter. And they're not ever intended to be called by user code. So they're all stored on a hidden class called RubyVM frozen core, and it isn't actually exposed to Rubyland. So you can't actually get at it. If you try and type in RubyVM frozen core, you'll just get an exception. But here's the definition of it inside MRI. So this is part of MRI's C code. This is in vm.c. So it's basically creating a new class that inherits from basic object. It's setting the flags on it to TI class, which is basically a fancy way of saying hide this completely from userland. This isn't intended to be seen. And then it defines a bunch of methods on it. So we can see the frozen core being used when you define a method. So this is just the bytecode that's generated when you type def foo end. So it puts 2 special objects, then it puts the name of the method you're defining, and it puts the instruction sequence, which is the method body. And then it calls a method called core hash define method. And that's actually a method on the frozen core. So whenever you type a bit of code like this, def my method 1 + 2, that is actually turned by something similar to that by Ruby. So it's actually sending a method called core define method against an object called frozen core. It passes self, so the class that you're defining the method on. It passes the method name, and then it passes the body of the method. This is all pretty loose and vague, but it's pretty close to what it actually does. So these are the sort of methods that are on frozen core. There's a whole bunch: set method alias, set variable alias, and all of these are called internally by Ruby. And I've sort of translated what these methods do and how you can actually get them to be called from Rubyland. So the set method alias method is called internally when you use alias syntax to alias one method to another name. And then when you use the same syntax to alias a global variable to another name, it'll actually call another method called core set variable alias. When you undef a method, it'll call a method called core undef method. And it also has 2 methods, one called define method, one called define singleton method, which are called respectively. When you use the capital End syntax, that calls set post-exe. That's basically similar to add exit. And there's a bunch of others. There's a method called when you when you use the hash literal syntax. And there's methods called when you use the lambda syntax. So what I said before, how do I go back? Shit. All right, so what, I just skipped past a bunch of my slides. And I'm just making things worse. All right. There we go. So yeah, I said before, the Ruby VM frozen core class, it doesn't actually exist visibly from Rubyland. So we have to search for it with heuristics. We can get at it from Ruby, but Ruby doesn't make it easy. So this is a snippet of the code I showed earlier where frozen core is actually defined. And it's a class that inherits from basic object and it's hidden. So it's actually in VM.c. It's created just after the Ruby VM class is created. And the Ruby VM class is something that we can get up from userland. And because of the way that Ruby's or MRI's garbage collector works, objects that are allocated near each other in terms of time are often stored in memory at close locations to each other. So we can find the object ID of the Ruby VM module. And in MRI, object IDs are the pointer to the object in memory. And we can sort of scan around that object ID in memory. So we can go from minus 1024 to 1024 and just sort of offset pointers around where Ruby VM is. Then we can use the object space ID2ref method, which, given the object ID, if that's a valid object ID that points to a valid object, it'll give you that object back. Otherwise, it'll raise an exception. So these are the sorts of objects that we can see that are living around that area in memory. There's a bunch of fixed nums, there's a float, and there's just some random string. And then we can search specifically for objects around that area that are classes. So we can see that there's thread singleton class, there's Ruby VM env, there's a numerator yielder, and then there's this interesting one which doesn't have a name. It's a singleton class of an anonymous class. And if we use find and look for a class that has an instance method defined called core define method, it actually turns out that this class is the class that we're hunting for. So this is the frozen core that we're not supposed to get up from Rubyland, but we've got it, so we can have a play around with it. We can assign that to a name, so we can use it by name instead of repeating this code everywhere. And the interesting thing is it's technically a singleton class, so we can't create a new instance of it. So we can play around with it. We can, if we want to get at the actual instance of this class, we need to do some hacks. So we need to alias the setPostXE method, which I was talking about, which is actually called internally when you use the end syntax. So I'm going to alias that method to another name. I'm going to redefine it to just return self. And then I'm going to use that end syntax and assign it to a global variable, and then we'll just restore the old method. And when we do that, we've actually gotten up the instance of frozen core. And this code is not code that you're going to want to repeat everywhere in your projects, and you're not going to want this code running in production. You don't want to write it yourself. So I wrote a gem for it. You can say gem install frozen core, and that'll expose the frozen core class to you, and you can go ruby VM frozen core.instance, and you can get the instance of it. So this is an example of aliasing a global variable. We set the global variable A to 123, we alias it to the name B, and then B is also 123. We can also call directly into frozen core. We can call core set variable alias, give it the new name of the variable we want, and it aliases it, because that method call is what is actually happening internally when you use the alias syntax. We can override how hashes are constructed. So we can redefine the hash from array method, and we can actually reverse the key value pairs. So then when you have a hash of A1, B2, C3, you actually get C3, B2, A1 back. And you can actually override method definitions. So one of my favorite features about Ruby 2.1 that you may or may not have seen is that method definitions, instead of returning nil, as they did in Ruby 2.0 and below, they actually return the method name that you just defined. So by overriding core define method, we can actually backport this feature to Ruby 2 and below. So all this is doing is it's taking the old copy of defined method, it's binding it to the frozen core, then it's redefining that. And all I've done is I'm just returning the method name at the end. And as you can see, that actually works. So the frozen call methods, they assume that they're only ever called internally. So they can easily crash if they're called the wrong way. You've got to treat them with extreme care. So this is the implementation of hash from array. This is real actual C code from MRI. And you can see that assertion just above the while loop that actually asserts that the array that you pass in has an even number of elements. So if you call that method with an array with an odd number of elements, then Ruby crashes with an assertion failure. There's also set method alias, which will just alias the methods that you pass in. But note that this doesn't actually do any type checking. It assumes that the class that's being passed in is a class because it assumes that it's only ever being called internally. So if you call it with something that's not a class, you get a segfault. So that's my first magic trick. That's the frozen call. You can do some really cool stuff with that. But in my opinion, at least, it's not nearly as cool as my second magic trick, which is changing superclasses. So have you ever hit an issue with, say you're working on your Rails app and you've done something that sort of messes up Rails autoloading, and all of a sudden you get an exception superclass mismatch. You've got your user's controller. It's supposed to inherit from application controller. But for some reason, it's throwing an error because it's inheriting from the wrong class or whatever. So we can fix that by changing the superclass. It's super convenient. So let's look into what happens when you call dup on a class. So the Ruby method dup will just duplicate an object, and it works on pretty much every Ruby object. So when we dup the string class, we get a new anonymous class back that has all the same methods as string. It behaves the same as string. You can call new on it, and it's a real copy of the string class. We can call ancestors, and we can see that copies across the ancestry tree. So it has the same ancestors as string, except, of course, the first class is a different class. And this is basically how dup works internally. So it'll allocate a new object of the same class as what you're calling dup on, but it doesn't actually call initialize. Instead, it calls a special method called initialize copy, and it passes in the old object, then it returns the new object. So when you call dup on a class, that's allocating a new class, and then it's calling initialize copy with the old class. And this is the implementation of an initialize copy in MRI on class. So it does some basic type checking. It makes sure that you're not trying to copy basic object, doesn't let you do that. And it makes sure that you're not trying to reinitialize a class that already has a superclass. So if the superclass of the new clone is set, or if the clone is basic object, it'll just raise a type error and it'll complain that you've already initialized the class. And it'll also complain if you try and dup a singleton class. If all those checks are satisfied, then it will call onto mod init copy, which is the initialize copy method for the module class. And that does something like this. So that calls obj init copy. So this is basically like super calls. And it does some stuff, and then it copies over the superclass from the old class to the new class. And then it just returns the new class. So we can do this manually. We can create a new class called K. We haven't actually called initialize, so this is a completely uninitialized class. We can send the initialize copy method to it with a subclass of string, and we can see that when we call ancestors on the class, it's actually a subclass of string now because it's copied over the superclass from string. If we try and call initialize copy on a class that's already initialized, then we get a type error, and that's the same type error that we saw called in class init copy. But you may have noticed that all the type checks were done inside class initialize copy, and then it just forwards a call onto module initialize copy. So none of the type checks are actually performed in module initialize copy. So we can actually abuse this, and we can take an unbound method of initialize copy on module, and we can bind it to our K class, and then call it with a subclass of string, and that'll actually reinitialize an already initialized class. So before we did that, the class K was a subclass of object. And now it's a subclass of string superclass, which is comparable. So then we can do this permanently by just redefining class initialize copy to just call super. So we've effectively thwarted the type checks that it does. And then we can define a superclass writer that basically calls initialize copy with the subclass of the new superclass. And this actually works. So we have two classes, A and B. C inherits from A, and we can see that the ancestors includes A. We can reset the superclass of C to B, and all of a sudden the ancestor chain is completely different. We can even do this to built-in classes. So if we have a string hello world, we can call 2s on it and we get the same string back. But if we set string superclass to fixed num, and we call 2s on it, we get something that looks suspiciously like the object ID back. But if we try and do the other way around, then Ruby just crashes. Which, it's a little disappointing that we can't have all this fun if Ruby's going to crash on us. You know, wouldn't it be great if we could stop Ruby from crashing? Which leads me to my third magic trick, which is number 3, rescuing from segfaults. So when Ruby crashes, it prints out a big ugly dump like this. I'm sure you've seen this before. You know, you use all these crazy C extension gems that just crash all the time. This screen is certainly no stranger to me. So you'll notice that one of the bits of information that gets dumped out when Ruby segfaults is a list of all the loaded features. So these are all the C extensions and all the Ruby files that you've required in the running Ruby process. And this is dumped out in vmdump.c. And it looks something like this. It prints out a loaded features header, then it iterates over the loaded features array. And each line, it'll just print the index and the actual loaded feature string. So let's look at this call a little bit more closely. So VM loaded features is the way the VM refers internally to the loaded features global. It calls string value cstr on it, which is actually a macro which calls RB string value cstr, which looks a little bit something like this. So it calls RB string value on the pointer you pass in, then it does some type checking, makes sure that the string's correctly null terminated, so you get a C string back. But this call is something we're going to look into a bit more closely. This is what the RB string value function looks like. And you can see that if the type isn't a string, it calls RB str to str, which looks something like this. So if the string that it's trying to print isn't a string, it'll call the toStr method on it. So we've actually found a way that we can get Ruby to call methods on objects of our choosing while it's segfaulting. So if we put a fixed num into loaded features, we just unshift that in, and then we simulate a segfault by sending sig_segv to our current process. We can see that when it's trying to dump the loaded features, it'll actually raise an exception and it'll complain that it can't convert the fixed num that we've put in loaded features to a string. And then, obviously, that's an uncalled exception, so it just dies anyway. So we can make an object of our own, we can define toStr on it, we can print hello world, and we can exit. And we can unshift it into loaded features and segfault ourselves. That's supposed to say hello world down the bottom. Ignore that. But yeah, basically, it's calling our own method that we've defined on our object while it's segfaulting. So we can make good use of this by defining a segmentation fault exception. We can create an object. We can override toStr to just raise this segmentation fault class. And we can simulate a segmentation fault on the current process. And while the VM is busy segfaulting, when it gets to dumping the loaded features, it'll just raise a segmentation fault exception. And then, of course, we can rescue this. So we can send a sig_segv to our current process inside a begin rescue end block, and we can just put rescue from segfault. And then what actually happens is it segfaults, gets to where it dumps loaded features, and it calls our code, and the Ruby process is still alive. So I thought I'd do a little bit of a quick little demo on this. Where are we? if I can figure out how to get out of this presenter display. Never mind, that'll have to wait for later. Anyway, so yeah, we've seen 3 magic tricks today. We've seen frozen core, we've seen changing superclasses, and we've seen rescuing from segfaults. And these are all really cool things that you might have never thought possible with Ruby, but by just doing a little bit of digging inside the Ruby VM, we can see that there's a bunch of bugs that we can actually use to break Ruby. And it's no surprise because Ruby is a 200,000 line C project. It's under active development, and it is a complex language with many, many features. So it's really no surprise that it has the odd bug. So we're running quick for time, so I thought I'd do a little bit of a bonus round. Where are we? This is going to work for me. This isn't liking my key input. Can anyone see that, or does it need to be a bit bigger? A bit bigger? Bit bigger still. Cool. What's going on here? So it's not actually letting me type anything in here. Live coding, huh? Anyway, yeah, so I'm just going to cut it there. This isn't working for me. But yeah, that's 3 magic tricks in Ruby that you can do by just exploiting a bunch of bugs. So yeah, thanks for your time. I hope you've learned something useful, but in all likelihood, you probably haven't.